Hi everybody, these are the answers for our practice test on pressure. Our first question, when does a gas apply a force? Well, it applies a force when it hits the side of a container. Again, the collision is the key. That's when the force happens. Can a gas ever apply a pulling force? No, it can only push. There's no such force as suction. Next, what do we call the force of a gas or liquid atom molecule when it strikes a surface? Well, force is a generic word. When we have gases or liquids, we give it a specific name, which is pressure. And question 4, if we put some gas into a smaller space, the pressure will increase because it will have more hits on the container because it doesn't have to travel as far. And this goes right with what we did with the big and small boxes. You were able to get a lot more collisions with the small box than you were the big box, and the number of collisions indicates the pressure.
Okay, question number 5. If you keep the volume the same but take some mass out, think of mass as number of atoms, the pressure is going to decrease because it will have less hits on the container. So you can see the example here. If we look at the atoms in the blue, if we decrease, then they have less hits on the container. Question number 6, if we keep the volume and mass the same but decrease the temperature, the pressure will decrease because the atoms are making fewer hits because they are moving slower. So again, if you look at the blue atoms, we keep our volume and mass the same, but we're going to decrease our temperature. The atoms will slow down, again, making fewer hits on the container.
Okay, question 7. It says, explain why we cover when we cover the tip of the syringe and press the plunger back in, it comes back out. Be sure to tell of any pressure changes and why these occurred. This is basically our summary problem. And if I take the syringe and I plug it, I'm forcing that air inside the syringe into a smaller space, which raises the pressure. That basically means the inside of the syringe is being hit more than the outside of the syringe, and so we have a greater pushing force inside than outside, and that pushes the plunger back until it equalizes and both pressures are the same, because pressure always wants to be the same. Question number 8. Why did our crushed can crush? Where were the high and low pressures as well as how they were created? Now this is a very complex question. We're not going to expect you to do as much writing on the test as you're about to see, but you do need to understand the entire process. The first part of this process was the heating part of the process, where we had a little bit of water in the can and we were heating the water up until it boiled. Well, when we heated the water up and boiled it in this air as well, we made it warmer, which sped the molecules up, which raised the pressure. And since this pressure was high, it wanted to get out to the low pressure, which it did because we had an open system. Now, kind of a hard thing with this is when you have the high pressure here, we have high pressure with less mass, which is a little bit hard to get your head around. So if we go here and we reduce the mass to say 5, we know that under this condition by itself, we would actually have low pressure inside the can, but at the same time we've added a huge amount of heat, and that compensates for that. And even though we have less, they're going so much faster, the can maintains its higher pressure. And so that's the first part, which is the heating part. And it says mass in can was reduced by raising pressure with heat. Even though the mass was less, normally a sign of reduced pressure, the pressure was higher inside the can because the remaining atoms were going so fast, just what you just saw. Then we took it off the heat and we put it in this water bath. And what happened then was we basically put the brakes on the atoms that we're in. So when it was on the heat, we have the thing that's currently being shown, fewer molecules in the can, but going so fast that they were still under high pressure. But when it went into the water, we basically cooled those atoms off really fast all at once, slowed them way down, and all of a sudden we had way more pressure outside the can because the outside of the can was getting hit more than the inside of the can, and as that high pressure moved to the low pressure, it crushed the can and shoved a bunch of the water up into the can. And so you can see on this, when can was taken off the heater and put in cold water, the atoms inside the can immediately slowed down. Since we had less atoms than what we started with, because we expelled them from the can with heat, we had a reduced mass inside the container leading to low pressure. The outside air crushed the can as it pushed to get back into the low pressure, and the pressure also pushed a lot of the water in.
Then we have question number 9. Our vacuum chamber can reduce the inside pressure by taking mass out. And then finally, question number 10. The reason we can't pull the vacuum chamber apart when the inside mass is reduced is because we have more pressure on the outside pushing down. You can see all the high pressure here pushing in all directions around the chamber, pushing it down. We have low pressure inside the chamber, so the high pressure is preventing us from pulling it apart. That's it for our practice test. Good luck on the test.